Said, I'm the technician in the engineering technology department, and I'm here to show you our antenna measurement station. This is a prototype, so please bear with us in the quality of construction. However, it does accomplish what we need it to do. The goal of the station is to rotate as a standard antenna. You will construct an antenna, install it in this device, and it's an antenna rotator. This will rotate the antenna a precise amount to a precise angle. And you'll be monitoring the signal strength of the antenna over your station. This is actually a Radio Shack rotator, antenna rotator. There is a north orientation here, an arrow with a hash mark on the base. This shows 0 degrees on the indicator up here. And I have a remote control. To set this, first let me show you how to install the antenna. We have a standard 2.4 gigahertz internet router. According to the standard, you're allowed to make any antenna you like. The only legal limitation is the amount of power. The antenna is completely up to you. So what we've done is we've taken the external antenna off, put on a BNC connector, and fed the cable through this piece of pipe up to the top, where I have another BNC connector with a pair of alligator clips. Open up this clip and you can put in your piece of dipole that you'll be making in class. This will be your standard dipole. This length is going to be on the order of 5-6 centimeters or so. You'll be calculating that. Cut slightly long due to end effects and various other considerations of the antenna. Put the two pieces of dipole in the alligator clips. Lower them down to a very small notch you see here. There's a notch cut in the pipe. This notch is also oriented with the north, so this will give you a good orientation for your antenna. Okay, the name of this router, when you're looking for the signal, you'll find the name written on the label on the side. This is eTech Lab 1. We have 2 and 3 as the other two stations. All right, in this version, you'll have a remote control. If I wanted to program this for 90 degrees, I give it 3 digits, 0, 9, 0. And as you can see, this bursts into action and very rapidly rotates to the desired angle. The current angle is shown on the display, and before too long, it will arrive at 90 degrees. Okay. To return back to the original position, you would type in 3 zeros. To do a complete 360, enter in 355, and that'll allow it to do most of 360 degrees, and it saves you the boundary error. If you find over time that this begins to drift out of calibration, if it gets more than a few degrees off, press this button here in the center and hold it for a second or two. The antenna rotator will automatically recalibrate itself. It'll rehome itself. It'll go to 0 and then come back to whatever your last programmed angle is. So this is it. It's an antenna rotator with a north orientation. Insert your antenna into these 2 clips. Center conductor in the gold and the outer conductor in the silver. Rest it in the 2 slots and rotate away. And our next stop will be over at the computer where I can show you our signal strength measurement software. The software we've chosen is freeware. It's called, yes, I've just been told by my director. On this side, we're going to be using a Cisco wireless USB connector. If you have a laptop with you, you can use the wireless detector inside it. What we need is a wireless receiver on this side. This subscribes to a standard called NDIS 5.1. It's a standardized way of accessing the industry variety of wireless receivers. And from this we will be getting the signal strength, also known as RSSI. Which will give us a relative measurement in dB. The units are in dBm, but unless it's truly calibrated, your mileage will vary. I will start the software. It's called Insider. That's INSSIDER 2.1. This gave the best controllability and the quality of display. And it, as you can see, it is already, okay, down here, there's the welcome page. We'll be interested in the time graph, which is giving us an ongoing signal display of the strengths of all the wireless in this corner of the building. And what I'm going to do is I'm going to filter all these out. eTech, positive filter, and it left us with just one. I entered in eTech in the top box of the scan and checked plus for the filter, and it left us with just ours. You'll see an ongoing graph of the signal strength. Over here it shows the amplitude in dBm, which again is relative. And up here on the display, it's showing an RSSI of it's giving you the most recent reading. And it fluctuates quite a bit. Over time it will stabilize to a level reading, and as you can see it is now. But there will be a history of dropouts and wandering readings on this. You will have to take a number of readings and average this. We will go now to our time display. And this is showing you the incidental time at the bottom. It's 1:33, 1:34 in the afternoon. You're seeing a bold chart here. To make the readability easier, I'm going to deselect up here, and it goes to a fine graph. Okay. So that is essentially it. From here, you'll be taking your readings of the signal strength, and when you have established a baseline, you take the remote control and program it to do a 180-degree sweep, and you'll see the power rise and fall as you watch the various lobes go by in the pattern of your antenna. Get a maximum and minimum. You'll see anywhere from 10 to 15 dB is a null. And try varying antenna lengths, because you'll find as they get longer or they get shorter, you wind up with different patterns. And with this, I will conclude our training for today. I wish you the best of luck in your lab. Thank you very much.